Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7 on cubic function. It says given f of x is equals to x cubed minus x squared minus px plus q. Point t is negative 4:3 is to 18 is to 18 whole number 14 over 27 is a stationary point, and f when x is negative 3 is equals to 0. A and b are the x-intercepts, right? So we have A and B being the x-intercepts, and then we are given that these ones here are stationary points. So we have a stationary point at point T there. And then we are told that f negative 3 is equals to 0, meaning which one? This one here is an x-intercept at that point, right? So this obviously represents an x-intercept. When x is negative 3, then our y is 0. Okay, then 7.1 says show by calculation that p is equals to 8 and q is equals to 12. So from here, we can tell that our q here is supposed to be our y-intercept. And then obviously our p-value, we are going to get it by deriving this to the first derivative and using our coordinates for point t, more specifically our x coordinate, right? So negative 4/3, right? So, okay, let's try to calculate the value of P and Q. So, first step is that we are going to take this, say f prime x is equals to 3x squared minus 2x. And then if we want to derive here, we are going to have minus p. Obviously, the derivative of a constant value is just 0. But then we do know that at point T, this is the stationary point. So we are going to say f prime x is equals to 0 at stationary point. At stationary point. So that means we are going to have 3x squared minus 2x minus p is equals to what? 0, right? But then remember the x coordinate at the point, at the stationary point is what? X is equals to negative 4/3. So what we're going to do is just substitute the x coordinate of the stationary point where there's x, because mainly what we are saying, we are saying that the gradient at this point, here on the stationary point will be equal to 0, right? So the gradient at that point will be equal to 0. So which point are we talking about? We are talking about this point there with an x coordinate of negative 4/3. So square that, minus 2 and then negative 4/3, and then minus p is equals to 0. So at this point, you already understand what I'm doing here. So this is 4/3. And then we have square minus 2, we have a bracket negative 4/3. And then if we punch all of that into our calculator, we get 8 minus p is equals to 0. And then obviously to find our p value, we can take the negative p over to this side. That will give us 8 is equals to p, which can be written as p is equals to 8, right? So we have used the derivative in order to find the value of p. Now, to find the value of q, we can take advantage of the fact that we already have these coordinates here for this point here, negative 3 is to 0. And then what we can do is we can substitute this coordinate here. This is negative 3 is to 0 into the original equation, because remember, the negative 3 is to 0 lies on the original equation of f of x. So this is f of x is equals to x cubed minus x squared minus px. But then remember, I already have the value of p. So I can just go ahead here and say minus 8x and then plus q. So what I'm looking for is that q value there, which happens to be the y-intercept. So using these coordinates now, I'm going to say where there's f of x, let me put 0. And then where there's x, I will just substitute in the 3, right? Now, again, I could have also done it with the coordinates of t, right? Just because with the t here, I can see that it can be a little bit complicated with this number here. So I'm just going to, choosing to go with the simplest one, right? Just choosing to go with the simplest coordinate, then plus q. At this point, you just want to punch all of this into umshinwe your calculator. So this is -3, and then to the exponent of 3. And then here we have minus -3, and then square, and then -8, and then we have -3 like that. So this gives us -12, and then plus q. So to find our value for q, again, we can take the -12 over to this side. It becomes +12, and then is equals to q, which can be written as q is equals to 12. So just like that, guys, we have shown by calculation that p is equals to 8, and then q is equals to 12. You will remember with this kind of questions, I did mention that it is just a matter of substituting into the derivative equation and also substituting into the original equation, right? So always note that when we substitute into the derivative, we use the x coordinate of the turning point, and then we make our f prime or our derivative function equal to 0, because we are saying at that point, that's the stationary point, and at the stationary point, our f prime is always equal to 0. So always note that. So yes, we have proven that, guys. And then done with that, 4 marks in the bag now. Okay, so now we have 7.2, and then you will remember the strategy that I did tell you, that if you ever fail to do your 7.1, you ever fail to get your P and your Q there, you can still continue solving all these other questions, because all you can just say is that, okay, I am already given that P is 8 and then Q is 12. Let me just substitute into this equation and continue using the equation there to find the coordinates, right? So, okay, what we are going to do now is we're going to go to 7.2. And then for 7.2, they're saying calculate the length of AB. Now, at this point, we can see that the coordinate for A we've already been given through the use of this point here. So through the coordinates here, -3 and then 0. So we can all see that the only x-intercept that we have on the negative x-axis is this one. So we have -3 over here. And then what's the b value here? Now remember, to find the b value now, we can just say we have f of x is equals to x cubed minus x squared. And then remember, p is what? 8. So -8x and then plus 12, right? At this point, we want to use our synthesis method so that we can factorize this polynomial here. So remember, how do we go about with our synthesis method? So this is how we do it. So already from this, we can see that our factor there is -3, right? So we have our x-intercept there is -3. So we're going to have 1, 2, and then 3, 4, right? So we're just going to put this one here, -3. And then let's go. So the first one that we have here is what is 1. So remember what we do in our synthesis. This normally drops down. So this normally drops down and then goes all the way here. And then here we are supposed to put the coefficients of all this. So we have 1 here for the coefficient. We have -1, and then we have -8, and then we also have +12. So what we do is we first drop the coefficient here, the first coefficient over here, and then we just go and multiply with the factor there. So -3 multiplied by 1, that's going to give us -3. So now we're going to have -1 minus 3. Negative 1 minus 3, that's going to give us minus 4. And then again, what do we do now? We are going to take this negative 3 and then multiply it by the negative 4 here. So negative 3 multiplied by negative 4, that's positive 12. And now we're going to say negative 8 plus 12, which is going to give us what? 4. And now we can say negative 3 multiplied by 4, that will give us negative 12. Now, if you say 12 minus 12, that's going to give us 0. Right. Now, what do we do with this factor? Remember, if we have to write it in factor form, if this is negative 3, then we know that it's supposed to be x plus 3. Right. So basically, if we have it as a negative, we then have to write it as a positive so that when we equate it to 0, it gives us back this negative 3. So if we can say x plus 3 equal to 0, we will still get that negative 3. Right. And then what do we do with these ones? These ones, and this is where we form the quadratic pattern, the quadratic equation or the parabola equation by saying our coefficient for x squared now will be x, and then our coefficient for x will be negative 4, so negative 4x, and then over here we will have the 4. Right. So what we do now is we will try to factorize this part now. So this will give us x minus 2 and then x minus 2. Right. So remember, we are trying to find the x values. So the x-intercept. So we can equate this to 0. And then now we have our x-intercept as x is equals to negative 3 or x is equals to 2. So that's the synthesis method. Now the 2 here is telling us that this is the one that will go for B here. So why do we have two roots that are equal? So remember, if you are to write this, this is x is equals to 2 or x is equals to 2, which you're not going to say x is equals to 2 or x is equals to 2 because that's one and the same thing. But then basically, remember, if you have two roots that are equal, it means that that coordinate here, there is both an intercept and a turning point. As we can see with the shape of our graph, we have the B coordinate there being both the intercept and the turning point. So that means that's where we have the 2 here. Now, remember, we are not done. This is not all about calculating the x-intercept, but also finding the length, right? So since we are just having a horizontal line, there would be no need for us to use the what you call the distance formula to find the length. We can just say the length of AB is just saying the x-coordinate on the right minus the x-coordinate on the left, right? So that's the formula that we use to find the length of a horizontal line. So the x-coordinate on the right is 2 minus the x-coordinate on the left, that's negative 3. And then obviously we're going to have 5 units, right? So even if you were to take it like this, from negative 3 all the way to the origin, that's 3 units. From 0 all the way to a point B, that's 2 units, right? So if you add 3 units and 2 units up, you get 5 units. Right. So that's basically how you were supposed to calculate that. Yes. So 4 marks for that, for using the synthesis method there and being able to calculate your x-intercept. Right. Okay. So nice. We're enjoying ourselves here. Nice. 7.3 now is saying for which values of x is the function concave up. Remember, I did say that you cannot comment on concavity unless you first find the point of inflection, right? Now, at this point, we have developed a very easy strategy to calculate the point of inflection because now we understand that the point of inflection is just the midpoint of the x coordinates of the turning points. So here we have negative 4 over 3, and then here we did calculate that this is 2. So basically, to calculate the point of inflection, POI, we can just simply say x is equals to negative 4 over 3 plus 2. Remember, when I'm calculating the point of inflection, I'm only concerned about the x coordinates of the turning points. only the x coordinates of the turning points. And then all we can do is just now punch that into our calculator, -4/3, and then plus 2. And then we're going to go ahead and then divide that by 2. So the value that we are getting is 1/3, which can be written as 0.33 into 2 decimal places. So if you can predict it, it can be just somewhere there, just halfway between the x-intercepts, just halfway between the x coordinates, meant to say between the x coordinates of the turning point. So, but then we are not done. We are looking for where this graph will be concave up, right? Now, if you can look at this graph, we can see that it starts by being concave down all the way from here up until the point of inflection. Remember, the point of inflection is where the graph changes concavity. So at this point, it's not concave up, it's not concave down, right? That's where it transitions. Okay, so in red, this is where your graph is concave down, right? And then after that point in green now, that's where your graph starts being concave up, right? So we can say it's concave up starting from that point going in that direction, right? So starting from this point going in that direction, we can see that our graph will be concave up. So how do we write that mathematically? We are going to say when x is greater than 1/3, right? So when x is greater than 1/3, that's where we have our graph being concave up, right? Okay, now we have 7.4. It says, determine the equation of the tangent to the curve at the point where f of x changes concavity. Now remember, I just mentioned right now that the point where the graph changes concavity is known as the point of inflection. So in other words, this question is asking us to calculate what? To calculate the equation, or to determine the equation of the tangent that will be passing through the point of inflection, right? So basically that's what it's saying. Calculate the equation of the tangent that will be passing through the point of inflection. So remember, we have our 1/3 here. 1/3. Okay, so now in order to do that, let's first try to draw how the tangent would look like. So if the tangent is to pass there, remember the tangent only has to touch once with the curve, right? So that means we are looking for a graph that might look something like this, right? A graph that looks something like that. Okay, so that means number one, we can see that this graph here will have a negative gradient since it's a decreasing line, right? It's a decreasing line. So we are looking for a line that will have the minimum gradient possible. That will have the minimum gradient possible, right? So at that point, this is where we have the minimum gradient on the curve. Okay. So for 7.4, first thing that we are going to do is we already have our x coordinate, it's 1/3. Now, remember, if we are to write the equation of the tangent of a tangent is a straight line. It's mx plus c. So there are two things that you need. You first need the gradient, and then you also need what? A set of coordinates, right? So in order for you to determine the equation, you need the gradient and a set of coordinates. So that means number one, we can calculate the gradient, right? By saying f prime x is equals to 3x squared. So I'm deriving this one minus 2x. Remember our p, we said it's 8. So that's -8 like this. And then what do we do now? We are looking for the gradient at that particular point. So to look for the gradient at that particular point, it means now we have to do this. F prime when x is 1/3, right? Remember, we can't put 0 because we are not on the stationary point. We are trying to calculate that gradient. So this is 3. and then 1 over 3, and then square, minus 2, 1 over 3, and then minus 8. Now you take your calculator, umshini weyibalo, and then you punch all of that. So we have 1 over 3 to the exponent of 2, and then minus 2, 1 over 3, and then close bracket, minus 8. Right, so we are having our gradient as negative 25 over 3. Right, so therefore, our gradient is that. So now that we've found the gradient, number 2 is to find the y-coordinate. Remember, we already have this x-coordinate. So in order to find the y-coordinate, so that now we have a set of coordinate, we can just say, let's substitute into the original equation. So this is x cubed minus x squared minus 8x, and then plus 12. And then this is f of x when x is equals to what? When x is equals to 1 over 3. So it is very much common for you to find your answers in decimal form or in fraction form here. So do not be alarmed when you are getting your answers like that. Right, they are correct. Okay, so this is 1 over 3 to the exponent of 3. So you make sure that you punch everything correctly into your calculator. Double check. So you are doing this along with me. And then plus 12. So we are finding our y value now as 250 over 27. So meaning our set of coordinates are 1 over 3 is to 250 over 27. So now we do have the gradient, we do have a set of coordinates. Now let's calculate the equation. Let's determine the equation. So I'm just going to go with the formula y minus y1 is equals to mx minus x1. Now for those who prefer to just use this one, whereby you first calculate the c, you can also go ahead and use that one. It's one in the same thing, guys. So this is y minus 250 over 27 is equals to the gradient is what? 1 over 3. And then here we have x minus, okay, that's not the gradient. The gradient is negative 25 over 3. So the y-coordinate, the x-coordinate is the one. Okay, so what do we do now? Multiply inside with this. So there we go. We have y is equals to negative 25 over 3x plus, let's now punch in, negative 25 over 3 multiplied by negative 1 over 3. So this is 25 over 9. And then if we transpose this one over, that's plus 250 over 27. So that means y is equals to negative 25 over 3x. And then that, let's add those ones together. So this is giving me plus 325 over 27. Right. So there we go, guys. There we go. So negative 25 over 3x plus 325 over 27. That becomes the equation of the tangent to the curve at the point where f of x changes concavity. So at the point of inflection. Right. So pretty interesting question right there. So you just needed to interpret the mathematical language there. Okay, so 7.5 says if f of x is equals to k has one distinct real root, determine the value or the values of k. So now we are looking for where this has one distinct root, right? One distinct root. So if we can check here, we can see that the graph At all this given point, remember, if you are given f of x is equals to k, it means you can find the roots by just drawing a horizontal line. Remember, the k here is speaking to the y-intercept that you'll get there. So the approach to these questions is that you just draw horizontal line and kind of check how many times do those horizontal lines intersect with the graph. So you can see this one intersects 1, 2 times. And then 1, 2, 3 for this one, 1, 2, 3 for this one. So basically, all these points here, you will see the graph touching 3 times. You will see that line touching the graph at 3 different roots, right? So you'll have 3 distinct roots. But then remember, with our question, we are looking for only one distinct root. So yeah, horizontal line, horizontal line. But then if we can just look just up below here, let's say we are extending this. Let's say we are extending this graph, and then we choose to look below here. We choose to look below that point. We can see that now this horizontal line will now be touching the graph only once. Only once. Right? So one distinct root. Only one distinct root. So that means your tangent is only touching once. Or your horizontal line is touching once. But is it only there? Again, if we can extend over here, we can see that the same trend will occur over here, whereby that horizontal line will now start to touch once. One distinct root. So everything that you are seeing in green, all those straight lines that you are seeing in green, this is where your horizontal line will be touching the curve at one distinct root, producing only one distinct root. So what should be the values of k? Meaning the value of k should be above this point here or below this point. Now, obviously below this point, it's easier to see because we can see that the y-intercept here or the y-coordinate at this point is right here at the origin is 0. So we can say that occurs when k is less than 0. Or that occurs again when k is greater than this point. But what is this point here? Above the turning point or the stationary point. Remember, we were given this coordinates here to be the coordinates of t. And this y value here represents the local maximum point, which is 18, 14 over 27. So we can say when k is less than 0, or when k starts to be above that point. So above that turning point, we can see that your horizontal line will only be touching once with the graph. So it's when k is less than 0 or when k is greater than 18 whole number, 14 over 27. That's how you are supposed to write that. So 2 marks for that. 2 marks for that. So basically, again, here it's just a matter of understanding and interpreting the mathematical language. Right. So you know how to interpret the mathematical language, you can easily get that one. So this means just draw horizontal lines and see when does the horizontal line only get to touch the curve once. Then 7.6 says, give the values of x for which f of x is greater than 0. F of x is greater than 0. Okay, so let's check now. What does f of x greater than 0 mean? So f of x greater than 0, interpreting this mathematical language, it means where the graph of f is above the x-axis, where the graph of f is above the x-axis. So we are looking for the points where the graph is above the x-axis. Now we can clearly see that the graph is above the x-axis right at this point. From starting at this point all the way, you can see that the graph is above the x-axis, right? Above the x-axis. But this is 2 marks. So where's the catch? Remember here we had -3. Then we can see the graph is above the x-axis. But then at this point, it comes back exactly at the x-axis. So what's this point here? That's +2. So now we are going to say for all the points where x is greater than what? -3. So all the points from here going that direction, from there going that direction, we can see that yes, the graph is above the x-axis, but not at this point specifically. At that point, now it's exactly at the x-axis. We are not looking for points where it is greater than or equal to 0. We are looking for points where it is above the x-axis, not at the x-axis. So we are going to say x greater than -3, but where x should not be equals to 2. So we have to come and restrict that point, because at that point we can see that the graph is exactly at the x-axis, and what we are looking for is where it is above the x-axis. So it's a mark for saying this, but then also a mark for having to see that you need to restrict the x coordinate where x is equals to 2. Right, so that's basically how you were supposed to go about answering this question here. So it was a very, very interesting question for a total of 19 marks. So come back to this video, watch it as many times as possible, and try to understand the approach that I took into solving all these questions here. But then with all that being said, catch you on the next episode. Please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.